Hello coders. In last video we saw brute force approach for this question, and now we'll see the better approach for this question. And yeah, let me take you to the screen. Yeah, this is our screen. In this question, in last brute force approach, what we were doing ki we are taking a row and we are checking it with columns. First row all columns, second row all columns, third row all columns. Likewise, we are repeatedly all columns. That operation we were doing repeatedly. So can we reduce it? That instead of checking every time, if we store it in map and we just see key using find, then how much time it will take? Like if you store in map data structure, it will take n log n time. And if you are seeing it n times, then n cross log n, and log of 10 raised to 5, 10 raised to 5 to 10 raised to 5 into log of 10 raised to 5. It basically will not take much time. So in that, compared to 10 raised to 15. And next approach, what we can do here, key first we'll store all rows, or like you can store it as a string also or as a vector also. There is no any problem. We store all rows. I mean storing all rows in, not in vector data structure. I'm saying it, storing it in map it, and we'll store vector int and int. Vector int will be the row or the column, and map the number, will be the frequency of that row or the column in that grid. So likewise, we'll store it, and then we'll see ki if that row is present in columns, like if that map rows in that map row, it's present in column map, and we'll take its frequency, that if rows frequency and column frequency, and we'll multiply it. Why? Because it's basically think it as a set. We have a set of, like, it's not C++ set, mathematical set. In maths, if we had a set, and we have, like, we have two sets, set A, set B. Set A have x numbers and set B have y numbers. So total number of pairs that we can do taking an element from set A and set B, that is x cross y. So that intuition will, that logic will apply here. If we have here x number of rows and y number of columns, number of pairs that we can make here is x cross y. So that's what I have implemented here. I'll just explain the code. I'm not gonna write code here. I wrote code, and I'll go through it, and I will tell you how, like, why I have wrote that. This gonna I'll explain in next video, that how that it's basically I have done whatever my intuition was, that I did it in diagram. Like, I have it's premium, so it can draw its diagram. So with that we'll see in next video. So right now we'll see the better approach, that the map one. So what I was saying, if we that I want to store rows and columns, so I took map of vector int. This vector int will store row or the column, and this int will store its frequency, row and column. I iterated over the grid. I took row and increased its frequency. Then again I went through, like, I go through the column. This is basically, I'm taking column here. Like, I'm making a row of every column, and I'm increasing its frequency, column V plus plus. In this step, someone can say here, why can't we just do row dot find V, and if it is, then increase its frequency. Friend, what happens here, if we do like this, if we find V in that row, then what happens, it takes n cross n, sorry, log n complexity, sorry, and for all this it will take n log n complexity. And that checking itself like it's taking basically uh, it's taking more time complexity if we check every column with every row, like if every column with every row in that map. Why? Because columns can be repeated, and for the same column we are performing find operation that much time. So to reduce that complexity, what I did here, I just took that column also and I just map that column with that frequency. And now what I will do here, I'll take that column and I'll find that column with okay, I took that row and I find that row in columns map, and if it is present, like this, like column that find B, if it is present, then just multiply with it dot second and column B. It means multiply its frequency, and that will be our answer. And this it got accepted. That I'll show you. It got accepted, and the time complexity and its bits it's low, but yeah, this works, and the yeah, this is the better approach, and the time complexity for this is big of n square, and space complexity is also big of n square. And yeah, we'll see the best approach in next video. Till then, bye bye.